Hello everybody, welcome back to another math video. I'm Mr. Schmidt and today I bring you fractions, and I know how excited all of you are about that. However, if you are one of the very few students who doesn't love fractions and you feel like you're not very good at it, don't worry, because 3 out of every 2 people say that they're bad at fractions too. Well, hopefully by the end of this video we all enjoy fractions as much as Mr. Schmidt does, but we'll at least try to get it a little bit better than it was before. This video specifically is only going to cover adding and subtracting mixed numbers. So if you have not seen a problem like this here on the left, 3/4 plus 1/2, where you find a common denominator to add it together, or if you're subtracting and we need to find a common denominator to subtract them together, then talk to your teacher because you're probably on the wrong video, okay? For everybody else, let's get started. Every fraction in this video is going to be a mixed number or a mixed fraction, which is something that we see here on the left. Up to this point, I'm hoping that you've done at least a little bit of drawing of your fractions to help us convert from mixed numbers to improper fractions. This fraction on the left is 2 wholes and 1 extra third left over. And if we wanted to know how many total thirds, we would just have to count. 1, 2, 3, 4, 5, 6, 7 total thirds, which is the same as 2 and 1/3. If we wanted to convert the opposite direction, an improper fraction, to a mixed number, it's the same process. We draw out our picture. We split everything into fourths, except this time we count our 11 fourths right away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. In order then to convert it to a mixed number, we want to know how many wholes there are. There's 1 whole, 2 wholes, and there are 3 fourths left over. Many of you probably have seen an algorithm before, which is you take 2 times 4 and add 3 extra to get 11. That algorithm does work, but you have to just be really cautious. It's very easy to get it mixed up. Personally, I like thinking of the picture for most of these smaller numbers, and then when you get to really large numbers, that's when that algorithm is most effective. Let's take what we have started with and try a problem where we're adding mixed numbers together. There are 2 algorithms that I think are very effective. We're going to do one on each side of the page. The first one, the one that you probably see most often, is what I like to call the improper fraction algorithm, which is turn everything into improper fractions and then add it together. So for our problem on the left, we need to convert these to impropers. You could either think of 2 wholes as 6 thirds, because 6 divided by 3 is 2, adding in the extra 3, or you can do 2 times 3 is 6, plus your extra 2. The one on the left, either strategy would work, but you would get 15 fourths in the end. When we add fractions together, we need all fractions to be the same size, which means we need a common denominator. So I'm going to multiply both of the left pieces of the fraction by 4 and the right pieces of the fraction by 3 to get a denominator of 12. To give me 32 twelfths and 45 twelfths. I add those together to get my improper fraction answer of 77 twelfths. Reminding yourselves that the denominator does not change because the size of the fraction did not change when we were adding or subtracting. If your teacher is okay with an improper fraction, you are done with this problem at this point, but most of the time, you're going to have to convert this back to a mixed number. Since 12 is such a large denominator, what I like to do is I like to go 12 twelfths for 1 whole, 24 twelfths for 2 wholes, and I continue this process until I get over 77 on my numerator. Which is right here. So that's too big. So I know that the numerator should be 72 to get the largest number of whole numbers. If I count then, that would be 1, 2, 3, 4, 5, 6 whole numbers. And I'll erase here. So my whole number should be 6. The gap between 72 twelfths and 77 twelfths is 5. And the denominator is still 12. These are the same number. Most of the time, you're going to have to do both. Now, before we move on, I just want to talk about most of my students will get through this step and be okay. Many of my students will get lost in this process here at the bottom because the numbers will get very large. And they'll say, oh, I'm so bad at fractions, I got it wrong. We have to remember there are a ton of steps going on here, and getting one of the steps wrong does not mean that you're bad at fractions altogether. It means you got one step wrong, okay? And if we need practice on that one step, that's totally fine, okay? Now, the strategy that a lot of my students get very upset with that I don't teach right away, I call regrouping. They like to call it the shortcut, but both methods are correct. It's just the one on the right means that you need to understand fractions a little bit better to be able to get it nice and smooth. Once again, though, I need to find a common denominator because we are adding or subtracting, which is the same process as before, except this time we're going to leave the whole number as it is. So I get this. From here, instead of converting it back to improper fractions, I can actually multiply as these whole numbers. And I create this very unique looking number here. I kind of have a mixed number and an improper fraction mixed together. So in order for this to work, I take the whole number 5 and I write it down here on the bottom. Then 17 twelfths has to be split up. I can pull out 12 twelfths and create one whole number. And then I can have the leftover 5 twelfths that didn't become the whole number. I just combine what I have. And I got the same answer both ways. If I needed to convert it to the improper, I could multiply 6 times 12 and add the leftover 5. So this is our first example. These are both of our methods. You need to make sure you talk to your teacher to figure out what methods are allowed and what steps are need to be shown in them. But mathematically, these both should give you the same answer. Let's do one problem where we're subtracting mixed numbers. Once again, we're going to do both strategies. On the left, we're going to do the improper fraction strategy again. Just like when we are adding, we need to have a common denominator. In this case, I think 15 is probably best. So I'm going to multiply by 3 and then multiply both of these numbers by 5. As I'm writing this out, please know that there are lots of different possible common denominators. I'm just picking one of them. At this point, I'm hoping that you realize that if you don't pick the smallest common denominator, you just have an extra step of simplifying. From here, we need to convert these into improper fractions. Now, I realize I did this in the opposite order of last time, but it actually doesn't matter. 5 times 15 is 75, plus an extra 6 is 81 fifteenths. Either way, we're going to get everything into improper fractions. And over here, I get 55, as my friend 50 Cent would say, fifteenths. And I just have to subtract. Now, 81 minus 55, you probably have to write that out vertically, but to save us time, I did this one in advance, and I get 26 fifteenths. Remembering that the denominator does not change because the fraction did not change size. In order to finalize this problem, I have to pull out as many whole numbers as possible. In this case, that would be 1. And I have 11 fifteenths left over because the gap from 15 fifteenths to 26 fifteenths is 11 fifteenths. And that's it. I'm done with this problem. On the right, I then want to show you the regrouping strategy. Now, the reason why I actually did the one on the left in a slightly different order is because if you do it in that order, this step ends up being the same, and I get to this common denominator. Now, like before, I would just subtract the whole numbers and subtract the fractions, but there's one big problem here, which is right now, if I subtracted 6 minus 10, I would create a negative number. And this is why you need to understand how fractions work to do this strategy. Instead of just subtracting and creating a negative number, I can borrow a whole number and I can turn this into 4 wholes. But then that whole number has to move into this other thing. And if I remember that a whole number is 15 fifteenths, I can add that to the 6 fifteenths to create 21 fifteenths, which is the same as 5 and 6 fifteenths. It's just not in simplest form anymore. Then the number on the left does not have to change. And now I can do the regrouping strategy. I can subtract the whole number from the whole number and the fraction from the fraction. 4 minus 3 is 1. 21 fifteenths minus 10 fifteenths is 11 fifteenths. And wouldn't you know it, we got the same answer both ways. Okay, so I showed you 2 strategies here. Both of these are correct, but make sure you talk to your teacher to understand what strategy they want you to be using. As always, if you have any questions, please let me know.